Good morning, everyone. This is Abhipreet Aman of Computer Science and Engineering Department, bearing the USN 1BI 20CS 197. Today, I'll be explaining about the topic called NFA, which is non-deterministic finite automata. So, firstly, I'll define what it stands for. Like NFA stands for non-deterministic finite automata. It is easy to construct an NFA than DFA for a given regular language. The finite automata are called NFA when they exist many paths for specific input from the current state to the next state. Every NFA is not DFA, but each NFA can be translated into DFA. The fourth point is NFA is defined in the same way as DFA, but with the following two exceptions. It contains multiple next states and it contains epsilon transition. We can see that in the following image, non-deterministic finite automata. We can see that from state Q naught for input A, there are two states Q1 and Q2. Similarly, from Q naught for input B, the next states are Q naught and Q1. Thus, it is not fixed or determined with a particular input where to go next. That's why it is called non-deterministic finite automata. You can see that the formal definition of NFA is like NFA also has five states, same as DFA, but with different transition function, as shown follows. So here Q stands for finite set of states. Uh, Sigma stands for finite set of input symbol, which may be like A B C D E F G and 0 1 in its binary notation. Q naught will be the initial state, F is the final state, and delta is the transition function. Transition function is like when you put a particular input, then where should it go is defined by this function. So that's why it's called the transition function. Now, the graphical representation of an NFA uh, will be doing like an NFA can be represented by digraphs, or digraph means directed graphs means which has direction property called state diagram, in which the first point is the state is represented by vertices. Second point is the arc labeled with an input character shows the transitions. The third point is the initial state is marked with an arrow, and the fourth and last point is the final state is denoted by the double circle. You can see that all these points are followed in this particular NFA transition diagram. So the first one, I'll be explaining about this transition diagram. So this one is Q naught is the first state, and it is denoted by this arrow signs like that. This is start, and if we put 0 as input in this, then it can go to Q naught as well as Q1. Uh, Again, if we put at state Q1, if we put 0, it will go into the final state, that is Q2. And in Q2, again, after putting 0 and 1, will remain at Q2. And this is the last step. So more clearly in the above diagram, we can see that the current state is Q naught, state is Q naught, and on input 0, I already explained the next step will be Q naught or Q1, and on 1 input, the next state will be Q1. The next state will be Q1. When the current state is Q1, on input 0, the next state will be Q2, and on 1 input, the next state will be Q naught. So finally, when the current state is Q2, that is, this is final state, it is represented by double circle. On 0 input, the next state is Q2, and on 1 input, the next state will remain Q2 as well as Q1. So this was the first example. The second example is this, and transition table for this particular diagram is shown here. And the third example is uh, to design an NFA with these two alphabets. It will take these two inputs and accept all strings of length at least 2. So you can see that this is its transition diagram. This was the examples of NFA. I already explained the first example. Now I'll be going on NDFSM. Basically, NDFSM stands for non-deterministic finite state machines. So the question here is like L equals uh, W belongs to this one A and B. So A will be the required inputs. The question is W is made up of an optional A followed by AA, which is followed by zero or more B's. So here is the uh, diagram or transition diagram. We can see that this is Q naught is the start state, and on putting input epsilon on A on Q naught will be going over to Q1, and on putting A will be going over to Q2, and again putting A on Q2 will be going over to the final state Q3. Again on Q3, if we put multiple inputs as B, it will remain at the same last state. Now the example here is like A, B, 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 B. It's going to accept, since it has an optional A followed by AA or by zero or more B's. So we can see that here is an A which is followed by AA, and it this AA is followed by zero or more B's. Here, one case is there, like there are four B's. So this finite state machine is going to accept that this particular input. So that's why it's shown as accepted. In the second one, we cannot have uh, automata finite FSM starting by B. So this particular input does not satisfy this machine's condition. That's why it is shown as rejected here. So that was it from my side. Thank you and have a nice day.